Okay, so let's look at this example here. And now this is an example of a plane going through the origin. So the set of all vectors x, y, z such that x plus y plus z equals 0. So we're looking at a plane that goes through the origin. So obviously this is a subset of the larger vector space R3, right? So now, just like the definition says, the operations are inherited from the R3. So the vector addition, right? Holds. And the scalar multiplication is the same as in R3 as well. Okay, now, to show that this is a subspace, we only note that it is a subset, and then we're just going to verify that it's a space. So obviously the plane going through the origin is a subset of R3, so all three-dimensional space. Okay. So all we need to do is verify the 10 conditions. Now, we're not going to check all 10 conditions. We're just going to show the closure ones. But I recommend that you, for practice, go through all the 10 and show and prove to yourself that it does satisfy all 10 conditions. Okay? Now, well, let's just show the closure ones. Now, based on this condition, this must be true, right? So anything that's in this plane will satisfy this condition. So if we have two vectors, right, in this plane, two specific vectors in this plane, well, if we add them, right, so x1 plus y1 plus z1, right? So that's in the, well, here, let's do it this way. So we take two vectors, x1, y1, z1, and x2, y2, z2, right? So we take two vectors in P, and what if we add them? Right? What if we add them? Well, we get x1 plus x2, y1 plus y2, c1 plus z2, and so the question is, does this satisfy the condition? Okay? Is it closed? So now we added these two vectors, right? And is this still in this? Well, we have to show that these three components add up to 0. So we're going to have to show that x1 plus x2 plus y1 plus y2 plus z1 plus z2 equals 0, right? Well, if we just use the commutative property and just move things around, well, we get what? x1 plus y1 plus z1 plus x2 plus y2 plus z2 equals 0. Well, we know by the two vectors starting with, we know that this adds up to 0 and this adds up to 0, so we get the closure property. So it does. Okay. Now what about closed under scalar multiplication? Well, if we take a vector from P and we multiply it by any scalar, let's see what happens. So we take r times xyz, right, where this vector is from P. So we know that this is going to give us what? Rx, Ry, Rz. Now, does the resulting vector stay in P? Well, let's find out. Rx plus Ry plus Rz. This should equal 0, right? Well, if we use if we factor the r out, we get r times x plus y plus z, which is just r times 0, which equals 0. We're done. So both closure properties hold. Now again, I'll leave it to you to check the other 8, but they will indeed hold. But again, like I said, it's good practice. Anything else here? That's it. That's all I want to say. Have a great day.